What's up everyone, today we're going to show you how to make your own thermostat just like Nest or Ecobee under 40 bucks. I'm Sanchit.
I'm Venki.
And we like building sustainable tech just like you.
All the smart thermostats out there are way too expensive.
And saving energy should be for everyone. So we're going to start off with the hardware. The hardware has a development board, a temperature sensor, relay, and an OLED display, and a bunch of wires. So the objective is to control your room temperature. A few main things that we need to make this happen are reading the room temperature, so what the room temperature is at a specific time, or what we want it to be, which is the set temperature, and a switch, which is basically turning it on and off. So for these purposes, we're going to use Adafruit as a central hub, and we're going to communicate to our Adafruit hub with our Arduino code by setting up feeds and dashboards. So let's go over the wiring diagram. What you see on the right is a standard terminal block that you have in your HVAC system. In the middle we have the relay, and on the left we have our controller. So let's go over the controller and the relays first. The way that I've done this is all the points that need to be connected are color coordinated. So for example, the purple will be connected to purple, and so on and so forth. So the reason why there's 3 purples on the controller is because each of those will connect to a separate relay that triggers that specific function. So for example, you want to turn up the heat, the top relay will be active at that point. So now let's go over your house HVAC terminal block and the relays and how they talk to each other. So basically, if you short the power and the heat, so the red and the white, the heater will turn on. If you short the red and the green, then the fan will turn on. And if you short the red and the yellow, which is cool, the cooler will turn on. And like before, all the connections are color coordinated, so just follow the colors. We'll be going over the Adafruit setup and the code now. If you want to see the detailed version, click the link on the screen. So here we are setting up our feeds. We have heat switch, set temperature, and room temperature. This is basically me setting up all the ways that we're going to interact with the hardware. So here is my dashboard reflecting the same thing. So I have my room temperature, set temperature, and on the right I have my heat switch.
It's time to write some code for your Arduino. We've added all the necessary libraries. We have the MCP9808 library for the temperature sensor and the OLED library that we use for the display. The first section of the code will link the feeds with the code. We see all the 3 feeds that we created earlier. Here we create temperature sensor object from the MCP library we added earlier. If you don't have it already, go to the sketch section, include libraries, manage libraries, and you can type the name of the sensor and download the libraries. Here we configure the relay pin as output and initialize serial for debugging and configure the display. The IO connect function here interfaces with the cloud and initializes the connection. The next 2 lines of code here interfaces any change that happens to heat switch with the function call listed there. Function we show below here are the action that takes place whenever the changes in feed occur. This section of the code ensures that we connect to the cloud interface and wait till that action takes place. Moving on, we have the loop section of the code in which we call the IO run function. This keeps the hardware connected to the cloud, looks for any changes on the feed. The next section of the code is just converting your degree C to degree Fahrenheit. If the room temperature were to change from last time, we update it on the feed and move on. Coming back to the subroutine section of the code, this gets triggered whenever there's a change on a feed that we update on our dashboard. Here we change our heat switch 1 or 0, which triggers the function handle message, which changes the feed to high or low, where high corresponds to 1 and low corresponds to 0, and whenever the value changes, the corresponding action is executed. The handle set temperature routine gets triggered and we can take any necessary action. And now we are all set to download our code to our processor. We go to tools, see that the upload speed at max, CPU frequency at 80, and ensure the board is the right one. Go back, verify your code. Alright, seems like we're good. And let's click on upload.
Let's go over the hardware now. For those who want to see the detailed description of each piece, please click the link on the screen. So here we are. Here's our 8266 development board, powered by USB battery bank. We have the CP chip on this board, which is required for any serial communication that needs to happen with the chip, and that's how you burn your program. Let's take this relay here. It has 3 pins on it, VCC, in, and ground. VCC here is 3.3 volts coming from my development board, and my in pin is what is driving the output of the relay. Let's check out this display board here. It has 4 pins, VCC, ground, SCL, and SDA. SCL stands for serial clock, and SDA stands for serial data access. This is part of my I2C interface, which provides the interface between the OLED display and the development board. And this is chained to my MCP temperature sensor here. It also has 4 primary pins, VDD, ground, SCL, and SDA. It takes the same 3.3 volt power supply and provides the current room temperature to the development board through the 2-wire interface that we have here. The time that we've been waiting for. It's time to power it up. I'm going to go ahead and plug in the USB into the battery bank that I have here. So you hear the click. It's trying to connect to the cloud now, and it's connected. Let's talk to the hardware now. I've already logged on to my Adafruit dashboard, and from here I can control my room temperature and my heat switch. It states that the current room temperature is 86. I'm going to go ahead and change it now. So you can see that the feed is updating the hardware, and it's also displaying the current room temperature. So a really cool thing we'll be showing you in the next video is to send a command to your hardware via Google Assistant. To do that, I've named my thermostat as a boiler. So I'm going to issue a command. Okay Google, set boiler temperature to 95.
Boiler temperature set to 95.
Just killing. We'll be making another video for this, so stay tuned. Hope you guys enjoyed the video.
Like, subscribe, and comment below for more build ideas.
See you next time.